Hey, what's going on? Welcome to the very first lesson in this data structures and algorithms course. My name is Caleb. I will be the instructor for the rest of this course. We're going to start with some concept stuff and just kind of lay a good foundation, but much of this course will be hands-on. So it's not all going to be just concepts, drawing stuff up on the chalkboard. I do believe focusing on both concept and applied for data structures and algorithms is very beneficial, especially once you get to things that are more visual like trees and graphs. Being able to just draw that up on a chalkboard, erase things, that's going to make things a lot easier. So a couple quick tips right away. Have somewhere to sketch notes, whether that's a piece of paper, whiteboard or chalkboard, a tablet, or really anything, because any of the visuals I'm drawing up here, it would probably be good for you to go through that practice as well. Second, for any of the hands-on stuff, you will want to follow along for that. If you're not doing the exercises in your hands, you're probably not going to be able to answer data structure and algorithm problems as good as you could if you were to go through the exercises. Now we're going to take a topic that's often seen as quite difficult, challenging to learn, and we're going to make it an exciting, fun journey where you get to learn new things, apply those things, see how it actually is used in the real world, and also pick up a ton of skills that will help you with technical interviewing. If you are an experienced developer, maybe you just need to sharpen up on the data structures and algorithms, this will be the perfect course. Some of the first lessons might have some review, but I'm going to hopefully give you some insights when it comes to data structures and algorithms and not just go over beginner programming principles. If you are a beginner, then make sure you understand what we talk about as much as possible so that when we get to new stuff, you're not stuck thinking about previous things that you don't really understand that well. Data structures and algorithms is something that stacks in terms of skills you need. You're going to need the skills from previous lessons to be able to go into new lessons. That's going to be the most effective way to get through this material. But as a result, if you skip something or you don't understand something super well, it might come back and bite you. So I'm not going to teach you how to program. I have other resources for that, but I will teach you some of the fundamental data types and data structures that for an experienced dev might feel like review, but we're going to approach it from a data structures and algorithms perspective. What does that even mean? I'll give you a very quick example, and there will be a lot more like this throughout this content. If you have some strings such as hello, and you wanted to append some data to this so that the string says, hello, Caleb, this is a fine operation, but if you're going to be doing a bunch of appends, this is actually a pretty bad operation. We'll get into the details later when we look at strings closer up, but say you were parsing some data and you were using a loop and you were continually appending data to this string. From a DSA perspective, it's a bad thing to do, and as a result, many programming languages have some string builder or some trick to get around this bad operation. So this is just one example where having a better understanding of the data structures and algorithms that power everything, you're able to have a stronger understanding and software development skill set. So will this help with regular programming? The answer is absolutely. Will this help with interviewing? And I'm going to have to say yes as well. But I want to say one additional thing. Interviewing itself is a skill. Because of that, I highly recommend doing some mock interviews. You can find some people to do this with in the Code Breakthrough community, or there are a ton of different mock interviewing websites. You can do it peer-to-peer, it's free. You'll interview someone and then they interview you. This is a great way to get started. I would recommend do at least 5 of these. The chances of your success in a real interview after doing some of these mock interviews goes up substantially. So get practice with the interviewing. You'll also see different issues people commonly make, and that's going to help you be better at interviews. So doing the mock peer-to-peer is really valuable. Regardless of whether you are looking to do interviews or if you're just looking to become a better software engineer, this material will definitely help you, and I highly encourage you to stick through to the end. Not a chance you'll regret it. You're going to learn a lot of things, and I think you'll find this material quite fun as well. So that's kind of an overview introduction. Let's now talk a bit about my approach to learning. If you follow along and you buy into this process, I think you will have a much better chance of success. Basically, first we start with the fundamentals, and you can think of this as an initial sweep. So we will cover the most important data structures. We'll get a little bit into some algorithms potentially, mainly focusing on data types and data structures. And I think you should focus on data structures first because algorithms are really just operations on data stored inside of a data structure. So if you have some array, sorting this data doesn't really make sense if you don't first understand how that data is stored in memory. Then we will do a deep dive. So we'll go back and learn those different topics in more detail. And this is intentional. So basically we want to get a good overview of a bunch of different things, and then we want to go deeper into each one of those things. What we want to avoid is you being an expert in arrays, but you've never even heard of a hash table, for example. So what we're going to do is we're going to become pretty familiar with a variety of different data structures and some algorithms. And then now that you're generally proficient, you'll have a much better time going in more depth and understanding everything at a deeper level. I wanted to specifically call out trees and graphs. We will get into this probably after we go through a deep sweep of some of the stuff we already talked about in the fundamentals, but we're not going to cover this much in the fundamentals. You might get a few examples or a couple visuals so you have an idea of what they are, but we're not really going to learn these data structures or the algorithms to work with them until after we get pretty comfortable with everything else. And the reason I say that is because I do believe trees and graphs is a step up in difficulty, but I believe if you're already an intermediate with data structures and algorithms, this is just an adaptation. You can use a lot of the principles you've learned from previous topics to pick up tree and graph algorithms quite easily. So don't let this topic frighten you if you've ever tried this before and you're like lost. Don't worry, we're going to be experts by that point in many different topics. So you'll be able to work with trees and graphs without any problem. So looking forward to this material. I will definitely help you understand these structures and help you get comfortable with some algorithms to work with trees and graphs. And the last thing with the approach is we will always do concept plus practice. You don't want to neglect either one of these. So for example, if you neglected the concepts, you might be able to answer some LeetCode problems, but you're going to be focusing way too much on memorization, and you're not going to have strong data structure and algorithm intuition so that you can talk about potential other solutions, what different trade-offs exist, and why you chose the certain solution that you chose. Instead of thinking of DSA as just a question and answer, don't do this. You want to instead reason about the problem so that for any answer you do give, you can justify that answer and explain why it's the best given the problem. A lot of that magic happens in the conceptual portion of this course, where we talk about why certain data structures exist and why you might want to use them. Learning those concepts is going to help you a lot with choosing the right data structures and algorithms. But if you skip the practice portion, you might have that theory figured out, but when it comes to applying that to any real data, you're not going to be able to do it, or you're not going to be able to do it fast enough to be able to succeed in technical interviews or screenings. So let's focus on the concept and the practice. So that's the general approach, but the next question is, what programming language? And I think people use this just as a way to make up excuses as to why they're not progressing. Ultimately, it doesn't matter if you were learning the data structures and algorithms, but if you're unsure, let me explain why I would suggest Python. This is the language we will be implementing stuff in this course. And if you are a Java dev or a JavaScript dev or C# or Rust dev or whatever, you might be looking at this and, oh, great, this course isn't for me. And that's a problem with a lot of devs. They're too focused on the programming language and they're not worried about the underlying data structures and algorithms. I've talked with multiple developers who've worked in different programming languages. Many times I have tried to convince them to learn these principles using Python and they choose not to. And then at some point they're like, hey, actually you were right. If I'd stuck with Python throughout this process, I would have had an easier time. So first off, it's easy to read and write. It allows you to focus on data structures and algorithms and not focus on the language. If you don't believe me, try to solve some problems with a more complicated programming language like Rust, and you're going to take a lot longer to come to a solution. And that's just time being taken away from progressing farther in data structures and algorithms. Because if you become advanced at data structures and algorithms, you can translate DSA concepts into any programming language. Honestly, I think this is a more efficient path, but there are some other major benefits to using Python. So not only is it easier for you to read and write, but it's more universally known and understood. Translation, more people use Python, especially for data structures and algorithms. So actually, by going with the herd here, you can benefit the most from other people's explanations and examples. And this is especially important for interviewing, If you're doing an interview with an actual person, which is becoming more rare, that interviewer should be able to read your solution regardless of what programming language you choose. But if they don't know the language you choose, it is just one additional barrier they have to work through to understand your solution. Our goal is to make our solution seem as simple and elegant as humanly possible, not getting caught up on little language details, unless you're applying for a role that specifically needs some language and you know that interview is going to be done in a certain language. But my goal is to reduce friction for both learning and interviews. Then once you go through this course, feel free to translate it all to whatever language you choose. Additionally, when it comes to getting caught up on little language details, 9 times out of 10, the person trips up on some language detail. They don't know how to do something like reverse an array or grab the last element or just some basic stuff. Maybe you're working with an array, but the problem is asking you to return a string. What's the best way to do that conversion? You want to start familiarizing yourself with these common rudimental operations, and I'm going to call out a lot of these as we go. I'll be like, hey, this is an operation that you definitely want to memorize, so you're not caught up trying to figure out that instead of the data structure or algorithm problem at hand. And I would argue that Python has the easiest language interface, meaning the way you do those operations is the most intuitive with Python. So it goes back to the thing of just focusing on the data structures and algorithms instead of small language details or features. So if that's not strong enough to make my case of why you should use Python, that's fine. Use whatever programming language you want. But if you want to get the best results from this course, that is what I would recommend. And if you're definitely set on learning this for some other programming language, feel free to then translate that to the other programming language, either in parallel or at the end of the course. Once you understand the data structure and algorithm principles, you can then do it again with JavaScript, Rust, C#, whatever language you choose. At this point, you probably have what you need to start this course and be successful, but I wanted to give you a couple additional tips, and then I'll do an overview of the topics we're going to cover. Just a high-level overview so you know what to expect, and then we'll get into the details when those topics come. So let's talk about these 3 tips that will help your journey, make it a little bit easier for you. The first is to practice as you go. So don't consume too much conceptual material without applying it. We will go with hands-on stuff in this course, like building out a certain data structure or implementing some algorithm. But there are a ton of data structure and algorithm problems out there, so you can find additional problems on LeetCode or other practice websites that will allow you to apply some of the things you're learning to problems. I don't generally recommend LeetCode as the first source of learning, but instead learn the topic and then find associated LeetCode problems. The more practice, the better. Just don't practice one topic so long that you forget to go into new data structure and algorithm topics, because getting a good understanding of everything will help you be better overall. So there's a lot of crossover and a lot of buildup of topics. So don't practice one thing so much that you're not getting a good variety. Next up, practice over time. So this is a big one because some of this stuff is brand new to you if you've never done data structures and algorithms, or it might be perhaps a little bit more advanced than what you're comfortable with. It takes time for your brain to adapt and pick these things up. So instead of practicing 8 hours a day for a week and quitting, been there, done that, don't do that. Instead, spread it out over time. Give your mind time to pick up this information and put it in a more long-term memory. So what I did when I was learning DSA was I kept a log. Every day I would write what I learned. This not only helped me stay accountable, but it actually gave me confidence because I would look back and be like, wow, I actually have learned quite a bit. And then do less total time and more focus time. I think you're going to get much farther focusing on some data structure for a day, spending an hour or two, and then doing a practice problem and calling it a day and doing it long term, assuming you have the time, you're not rushed to learn this material. That's going to be a better route than just going through a ton of stuff in a single day, because a lot of that you're not going to remember. So I would just say anywhere between 1 and 4 hours. I would go on the closer side to 1, maybe 2 hours if you're not in a rush. But if you're actively job searching, then yeah, go as aggressive as you can. 4 hours or even more if you can focus that long is definitely going to give you more total output. It's just your efficiency of learning goes down with every hour you're doing this. So don't spend too much time that you're not really putting this into like a deeper level of your understanding. You want to be able to build a little bit each day and then become proficient. After a month, you're going to be like, wow, I actually have learned quite a bit, and you're going to make a lot of progress. And this is going to change a lot if you're working full time already. You're not going to have the time to put 4 hours a day. So keep it on the light side. Even if you're just doing like one LeetCode code problem a day and studying a little bit on whatever data structure and algorithm you're focusing on, you can get really good progress with 30 minutes even. Don't set a goal so high that you don't do it. And I'm just speaking from experience because I've done this about 1,000 times where I'm like, yo, I'm going to do this for 4 hours a day, and then I can't stick with the goal. And then the last tip here is to explore. Don't just come up with a solution to a problem and move on. Try to understand that problem. Look at variations to your solution. How could you make it better? What have other people tried? What is the complexity of your solution? Just go a little bit deeper and explore some of the surrounding topics like variations or different possible solutions. That's going to make you a better developer. You want to practice that now so you're not just memorizing and treating this very robotically. So instead of rushing through the material, spend more time learning why you are solving something a certain way and alternatives. There will be many examples that I gave you throughout this course that I basically had to choose over some potential alternatives. There's usually multiple ways to solve a problem, and I'm going to talk about some of those alternatives, but there's usually many that you can learn about. So whenever you're solving problems, just stay in that problem a little bit longer and understand it at a deeper level. So that's your introduction. Now let's just get a quick overview of what we're going to look at next. We're going to start with basic data types. Things you're probably familiar with if you've done some programming. So we'll talk about numbers, strings, arrays, dynamic arrays. We'll also explore hashing. So we'll look at hash tables and hash sets. And then we'll get into object-oriented programming. Why do you need object-oriented programming? Well, for some of the more complex data structures, we have to design those ourselves, and there's no built-in data type that we can use. Throughout this, we'll also explore abstract data types. We'll talk about the different ways to implement and the pros and cons. And then that will be our first sweep. After that, we'll go back through those data structures, learn additional algorithms, additional operations, and get a deeper understanding of each one of those. So then we have a rock solid foundation for us to then move into trees and graphs. And there will likely be more data structures and algorithms than what I just mentioned. I just want to give you an idea of what we're going to talk about. We got a lot of exciting things. If none of that means anything to you, great. This is the perfect course for you. Let's start with the basics and get that rock solid foundation. I will see you in the next lesson. See you there. Hey, what's going on? In this lesson, we're going to talk about working with numbers when it comes to data structures and algorithms. So this section, we're really going to focus on fundamental data types, and we'll get into some data structures as well. But understanding numbers is absolutely critical for data structures and algorithms, especially anything specific to whatever programming language you're using for data structures and algorithms. So for this, we're going to need some place to put all of our files. So I'm going to create a directory, which I'll call DSA. And from this directory, I will do all of our work. So we'll start off by creating a new file, and we're going to be working in Python. For some of this beginner material, we will just have basically scratch paper that we can just execute to try things. Eventually, we may end up building out more complex files, but for now, we will just have a learning.py or whatever you want to call this file. And then I have the code runner extension to be able to run any Python files from Visual Studio Code, just hitting this play button. So we'll say print hello DSA, and we will run. It saves and prints hello DSA. So this is the bare minimum you're going to need to be able to do. Now, since most of these applications are not going to be super interactive, we'll just mainly be hard coding things here. In other words, we're not going to have input. I'm going to go to the code runner settings right here. And in here, there should be something run in terminal. I'm going to uncheck that. And what this will do is it'll just give it in the output, which I think is a little bit clearer. We don't have all the terminal prompt and everything there as well. And if we continue to run it, it should clear out the previous run. So you can search previous, clear previous output. From here, we can now start with some basic examples. And I'm going to call out any important operations you need to be able to do pretty much from memory. So I'll call those out as we go. But to start, we're just going to talk about basic division and the different types of numbers. So generally, there's two classifications. integer types, and then floating point types. So here we have those classifications. We have int and we have float. There's also complex. We're not really going to be using that in this course most likely, but you might want to be aware of that as well. If you're coming from another programming language, they might split these types out into more types. So there might be an int 16, 32, 64, or a float and a double. Those are all variations you should be familiar with. The major things that I want to call out when it comes to numbers, especially for Python, is what happens with division with certain types, and what happens if we make a number that is very, very large. So we will create an example by saying 45 divided by, let's go with 6. This is going to give us 7.5. So in this situation, we are working with two integers, but the output is a floating point number with a fractional part. In many programming languages, this is going to give us an integer output because we're working with two integer values. So just to show you guys this real quick, I'm going to say learning.c. From here, I will include standardIO.h, int main, and then we will do a printf. It'll be a little bit trickier with C because it will complain about types. So if we do this output with a %f, it's saying, hey, we want to print this as a floating point value. And if we then do a 45 divided by 6, it'll complain about these types. Format specifies type double, but the argument has type int. So what we're passing to this output here is an integer. So even though the value should be mathematically a 7.5, because of the types, it's just going to give us a 7. So if you want to see that more, you can create a double variable, and this will be assigned 45 divided by 6. You can do it as a variable, or you can just cast the output of this operation, but I think this is a little clearer here. So we will pass output here. Now it's no longer going to complain about the types because this is a double format, and we can run it and see that it gives us 7.0. So even though it has that fractional portion, it crops it to 0. Basically, the integer operation happens first. That gives us 7, and then we just convert that to a double, which gives us 7.0. So if you wanted to preserve the 7.5, one of these is going to have to be a double. So we could say 45.0 and run it, and we get 7.5. So with C and many other programming languages, you have to be very careful with integer division and always focus on what types are being used for the operation. In Python, numbers are a little bit more dynamic. So if you use an integer, it may convert the output to a float. And also there's just one floating point number type. There's not float and double. That being said, it's not so much that Python is missing the double type. It's just that it's called float instead. So typically double refers to a 64-bit number. Float refers to a 32-bit number. In Python, float is 64-bit. So it is the equivalent as using double in other programming languages. Now, if you want to do integer division in Python, you just use 2 slashes here, and that will give us 7. So we have another operator in Python to mimic that behavior. You'll have to be really careful with types as well with variables in Python because variables are not statically typed. So when you create a variable, you're not saying, hey, this is always going to be an integer. That's pretty similar for JavaScript as well, unless you're using TypeScript. So with Python, just be careful with types. Now, the next major thing, which might be strange for you if you have been using other programming languages besides Python, integers are not capped in Python. This means we can create an integer as large as we want. So we can go in here and create some massive number, and it should give us a valid output. We run it, and we get that number. I mean, I didn't check the math, but if you did the same thing in C, we can get rid of this output variable. We will print this just as an integer, and then paste this operation. We run, and it says overflow and expression. And it's also complaining about the formatting because I said, hey, print this as an integer, which is typically 32 bits, and the argument has type long, which is typically 64 bits. So we can say LD to say that, hey, we're actually going to work with a long, another thing you don't really have to concern yourself with in Python. So we run this and we get a totally different output. Undefined behavior means we don't exactly know what will happen. It could crash, it could give us incorrect data and continue to run. So you just got to be cautious of that in programming languages that will have the possibility of undefined behavior. Many other programming languages, not Python, not C or C++, will wrap around. So instead of giving us undefined behavior, it will go to the lowest possible number and then continue to count up. In JavaScript, the default number is actually a floating point number, which is a little different than Python and C. And we're going to talk about some differences between programming languages, but I definitely don't expect you to know and understand how everything works and all the differences between programming languages. I'm just doing this as a way to call out some of the default behaviors and things you might need to concern yourself with. And even if you're not programming in one of those programming languages, it can be helpful to understand the different approaches to solving certain problems, specifically what happens when you create a number that's too large. So with floating point numbers, overflow is a little bit different. You can do additional research on that, but JavaScript did introduce a big int type, and that works very similar to Python's int type, which is not limited to just a 64-bit size. I wanted to show you one more example with Rust, and this is something you don't have to type out, but basically this will get one input value and give it to a variable that's of type U8. So Rust splits up the integer types into a variety, one being an unsigned 8-bit integer. This has a maximum value of 255. So then what happens if we do this, where we say x plus 1, the type of y is going to be U8, just from inferring this operation here, adding to a U8. But if it's already 255, what happens when we add 1? For this, I will run it from the terminal, and I will compile with Rust C learning.rs, and then this should give me a learning file, which I can then just run. And I will say 254, result is 255, run it again, I say 255, and it panics. That's kind of like an exception in Rust if you're not familiar with Rust already. Basically, it's a runtime error. You can change this behavior, but you have to do it explicitly with wrapping add, and then we'll pass in 1 to this. And now when we run this, we can say 255, and it gives us 0. So it just goes down to the lowest possible value, and this being unsigned, that value is 0. So you could change that number, and you'll see that in action. So 255 will give us 9. So it's vitally important you understand how Overflow works with whatever programming language you are using for data structures and algorithms. In Python, we have it lucky because we don't have to worry about Overflow, which makes focusing on the data structure or algorithm problem a lot easier. So a specific example of where you need to concern yourself with this would be if you need to get a midpoint or an average, anything where you're adding up data and then dividing. If that adding could potentially go outside of the bounds of whatever type you were using, you could get a runtime error or an incorrect output. Here's a Stack Overflow question talking about that. So they give a trick to calculating the midpoint to avoid handling overflow errors, but they didn't see a situation where the array got big enough to need that. So they could just instead do low plus high divided by 2 to get the midpoint. What's best practice here? And the thing is that they are working in C, so they should definitely do this option, because there is a chance that, hey, maybe they do end up working with larger data, and I think that's what this response even says, in case your program gets modified someday, and then it breaks your assumptions. So if you are working in C or any other programming language that could potentially overflow, then you might need to be a little bit more careful and do some of these tricks to allow to find midpoints or averages or anything that might require you to add up a bunch of data. In Python, you don't have to worry about this, so you can just do mid is low plus high divided by 2. So not trying to repeat myself here, but the important thing to understand here is if you are working with Python and you don't have to worry about the more complex variation of the operation, you can just focus on the problem at hand, which is likely just going to use this midpoint for something. I want you to focus on solving that problem and not getting stuck on language issues. That's another reason why I recommend Python for learning this stuff. And then if you want to then pick this stuff up in another programming language, you can then start to worry about some of those problems like overflow. So that's one thing you definitely want to understand is how overflow works. And the next thing I wanted to talk about is how you can get the max value for a set of data. This is an important operation you should just know how to do. So we'll talk about lists in more detail later, but let's just say we have some data here. Getting the max value in Python is super easy. You can just say max, pass in data. Running this, you should get 546. That's great. However, there is value in understanding how to get that max value manually, and you can think of that as just a mini algorithm we have to come up with a program to go through this data and figure out which value is the highest. So if you are just needing that max for some other problem, you could probably just use max. But if the question is to manually calculate the max value, here's how you would do it. So we're going to calculate the max. The first thing you need to do is have a starting value. And we need to ask, where do we get this starting value? And then do comparisons against all other values. So this will look something like highest seen, and we'll default it to data index 0. So that'll grab 5. And that is the highest one we've seen so far. Then we would iterate through all of the elements for D in data. If D is greater than highest seen, we will replace highest seen with that new value. And then at the end, we can print or return, if you're within a function, the highest seen. So this is the easiest way to start, and then I'm going to talk about some variations or some things to do to improve it. But we're just ramping up, so this will give us 546, just like the previous example. So we know we got the right value, but I wanted to talk about this starting value and the way we are looping. We need to ask ourselves, what should we initialize data with if it's just some kind of flag or some variable used to keep track of something throughout execution? In this situation, we started with the very first thing inside of the list. That's fine. It gave us the right value, but it has some problems. What if this was our data? Well, clearly there's not even a highest value, but we run and we get a runtime error. We generally want to avoid runtime errors. So in this situation, whenever we want to get the highest, we will initialize the starting value to the absolute most possible lowest value. In Python, to do that, you would say float and then in quotes, -inf. And now any data in that list that's seen is definitely going to be larger than -infinity. So when we run this, instead of getting a runtime error, we're getting -infinity. That's not the most beautiful output, but it is better than a runtime error. You could check if highest seen is -infinity and then give a different message if you wished. But I think this is pretty good. And it works with an empty list as well as lists with data. So if we put some more values in here, we run the program and it still gives us a value. So that's how you would check for the highest. If you wanted to check for the lowest, you would just flip this. Start with the highest possible value and then check for anything lower. This also has the benefit for the loop. We're not doing a second comparison of data we've already seen. So if we go back to what we had before, we started with that first value, and this first iteration of the loop would just compare that value to itself. So in other words, we start with 5, and then the first iteration of the loop, the first value is going to be 5. So this first check is kind of just a wasted operation. Not a huge deal, but that's one of the downsides with starting with the first element as well. So if you had to start with that first element, you might want to modify this loop so that it skips the first element. So that's pretty much what I wanted to cover in this lesson. I do have a couple of other little things that I'm just going to speed run through. You can learn the ins and outs of these things in more detail if you wish. But the first thing I wanted to call out is just to be cautious with floating point numbers. So if we create a variable a and say 0.1 plus 0.2, and then compare a equal to 0.3, we run this, and you'll see we get the output false. So mathematically, this would be true, but technically we're getting the value false. And that's because of the floating point values. They're not always going to give you exact precision, and as a result, you can get funky outputs like this. So there's a couple of different tricks to avoid that problem. One would be to use a decimal type. So from decimal, import decimal with a capital D for the second one here. Now the way you would use this, let's replace this line. We'll say decimal, and then in quotes, 0.1 plus decimal 0.2. And then we would compare to 0.3 in decimal. This should give us the value true. And then the last thing with numbers that I wanted to call out is bankers rounding. This can confuse you or give you incorrect answers, so you definitely want to be aware of this. Print, and we will round 2.5. We run this and we get the value 2. You might be used to rounding, if it's a 0.5, up to the next integer. But in Python, it uses bankers rounding, and it's always going to go to the even nearest number. So 2.5 is going to go to 2. But if we add 3.5, that's going to go to 4. I'm not a banker, but I think if you do this across many numbers, using bankers rounding is going to give you a more accurate number. So you can do more research on that, but the biggest thing is just to be aware of that. So that's your crash course on numbers and what you need to be aware of with different programming languages, rounding, floats and integers, overflow, as well as iterating through data and getting the highest value. These are things you should be familiar with. Thanks for watching. In the next one, we will talk about strings and arrays.